We are going very good. We know what's source code now, how to pull the source code, how to build it and generate the artifact. We need to understand what is continuous integration next. I'm sure you must have heard this a lot of time. Continuous integration, continuous delivery, continuous deployment, continuous this, continuous that. First, let's get started with our first continuous, which is continuous integration. And it will be easy for you to understand it because you already know now source code and you know the build process. Well, developers every day, whenever they're working in their agile environment, they will code, build, then test. This test is they are checking the feature that they developed. It's apart from the unit test and integration test. In the build, we already do integration and unit test. The next test will be the local test. They will see the code that they have written, the feature that they have added, is it working or not as per their requirement. If they find it good by themselves, then they will push to centralized version control system like GitHub. Like that, there will be multiple developers who will be doing the same process. They code, build, test it locally and then push it to the version control system. And this will be happening multiple times in a day. Now, if developer have got a requirement of adding a new feature, or there is a new module that they are integrating, they will keep working on the code. Their main intention is to write the code and see whether it works or not after the build, which they will do it locally. And that's the problem. So they'll be working on a certain time frame, a week, 2 weeks, and they'll be keep developing, keep building, keep testing locally and pushing the code. When they're pushing the code, they are merging the code with everyone in centralized version control system. So that looks good. So what's the problem? Well, we have one very serious problem. The code is getting merged but not integrated. Yeah, I know. And I'll explain you the difference. There is a difference. Merged we have seen, like we merge our code, when we push it gets merged to the remote repository. When we pull, it gets merged in our local repository. That's merging. We are bringing all the code together. But when the time when we build it and the build time comes in, we take all that collected code and then we build it. So developer A, developer B, developer C, all of them have tested their code locally, but when their code is merged together, did we build it? If we build it, we will find whether there are any conflict or any error or any bugs. If you keep doing it without integrating the code, without building the code together, if developers are keep merging the code for a certain period of time, a week, 2 weeks or a month, and then after that the code is built together, that's the time when you will see a lot of bugs, lot of conflicts and lot of errors. And to resolve them, developers have to halt their development and work in resolving the conflicts, the bugs, the errors. And it's a very, very painful process. Yes, it's slow and painful. Identifying the conflict and the bugs and the error and the resolving them one by one may need a lot of recoding. They need to code it again. And that's why we say integration is painful if we are doing after a long time. But there is a very simple solution to this. We build the code every time there is a commit. A developer makes a commit to a version control system. As the commit is done, at the same time we should have some tool that can fetch all that collected code, build it, test it again, and then report it back to the developer. That process is called as continuous integration process. This process can be very well understood with this diagram. Whenever developer makes a code change to a version control system, the code should be fetched. We should build it, we should continue the build process. Then there should be test, code analysis, quality assurance. Once this test passes, we notify it to developer. Any failure will also be notified to the developers. So whenever developer makes a code change, let's say we have around 5 developers. Out of 5, any one makes a code change to centralized version control system, the code is merged there. And then we take that merged code, we build it, test it. If it's a failure, we notify it to the developer. Developer will stop working, fix the problem, and then continue with their development. So this way there will be an assurance that the bug or error or any conflict will be resolved as soon as it arises. Rather than waiting and collecting all those issues for a long time and then fixing it, we fix it right then and there. This process is continuous integration process. So we continuously keep integrating our code. It's not just merging, we are integrating. And this process is called as continuous because it's done continuously. Every time there is a commit, the process repeats. It's done continuously. That's why it's called as continuous integration. Previously, we have seen build process. We have automated build process by using a build tool. But again, now we have more processes. We have the source code. We have to fetch it, build it, test it, notify it. And there would be more steps involved here. So we need a tool that can automate all this process. Such tool, we can call it as build server, or the most famous continuous integration tool, Jenkins. Jenkins can automate all this process. So we can do continuous integration with Jenkins. Jenkins started as a continuous integration server, but it's much more than that now. But since we're talking about continuous integration, well, Jenkins can do that very well, very easily, very conveniently. And the same process follows. We fetch in the source code from the developer. The developer will push the source code in version control, source control. Jenkins will fetch the latest code, build it, evaluate it, and then report it back to the developer. Jenkins is a Java-based tool that was created by a guy called Kohusuke Kawaguchi. I hope I'm pronouncing it right. It's a Japanese name. And this guy had fought with, you can say, one of the biggest companies on earth, which is Oracle, and made Jenkins open source. Kohusuke had developed Hudson. Hudson was the build tool in Sun Microsystem that was developed by Kohusuke. When Oracle acquired Sun Microsystem, then Kohusuke wanted to make Hudson open source, and he had resigned the organization and came out and have created a separate version of, you can say, created a separate branch of Hudson. He named it as Jenkins, and he made it open source. Because of that, Jenkins have tons of features today. If we start talking about Jenkins feature, it will be hours and hours, and we won't able to finish it. There are many features in Jenkins. Jenkins as a package comes with lot of goodies, but it's not just limited to its goodies or its feature that comes with the package. Jenkins' main power is its extensibility that comes from its plugins. Jenkins plugins are Java code written by a lot of open source developers out there, which will help integrate Jenkins with other tools. Or we can say Jenkins plugins add features to the Jenkins. It extends its functionality. So when I set up Jenkins, it will come with a lot of plugins and a lot of features. But if I want to integrate it with cloud, with my AWS cloud, there is no feature in that by default. but we can go to its plugins section, download cloud plugins and integrate it with the cloud. Likewise, there are plugins for for testing. Even software testers today are using Jenkins to execute their test cases, which helps DevOps a lot, because then we can easily integrate with software testers. As we are getting integrated with the developers now, we will get integrated with the testers also. So you can use Jenkins as a centralized platform and execute anything in your infrastructure by using its plugins and also its other features like nodes. So yes, if we continue talking about its feature, it will be just on and on and on. So I will conclude its feature with two things: open source, extensible because of its plugins. And since it's open source, there are a lot many people around the world who are developing its plugins. If you don't find any feature in Jenkins, look for its plugin. If the plugin is not there, then it will definitely come someday. I've been using Jenkins for a long time and I have seen various plugins that are coming in Jenkins, which is helping it integrate with variety of tools and services out there. Jenkins can be installed on any operating system. All you need is Java. You can have JRE or JDK and you can set up Jenkins on that. Jenkins comes as a var file which you can deploy on Tomcat application server also. You can run with java-jar command, or you can install Jenkins as a service, and in setting it as a service is the best option. Or latest, we have Jenkins that can be directly running on Docker engine also. We have Jenkins image that we will see later. So now without any delay, let's get started and set up Jenkins.